For this word problem, we read that two cars are traveling in opposite directions, and one car is traveling 10 miles per hour faster than the other. If they are 160 miles apart after 2 hours, what are their rates? All right, let's just sort of draw out the scenario first. Okay, we know that the two cars are starting off from the same location. Okay, so we have this car. Let's call this car 1. Okay, and car 2. Okay. Now here's the thing, right? The only thing we know is that they are 160 miles apart after 2 hours. Okay. We know the formula that we want to use is rate times time is equal to the distance. Okay. So if you can imagine now, okay, we have car 1 and we have car 2. Okay, so we got car 1, we got car 2. So do we know anything about their rates, anything about their times, anything about their distances? Okay. Well, we know one thing about their times, right? We know that they travel for 2 hours each. Okay, so we know that they each travel for 2 hours. What do we know about their rates? Okay, so if you read here, it says that one car is traveling 10 miles per hour faster than the other. Okay, so one car is traveling 10 miles per hour faster than the other. Okay, so if we call one of these x, okay, remember that we don't know, right? We don't know how fast car 1 is going, but then we know that car 2 is going to be going 10 miles per hour faster. We'll call that x plus 10. Okay. So now, what do we put here for the distance? What do we put in this box? Okay, so common mistakes is to put the 160 here, 160 here. Okay, another common mistake is to put 80 and 80. Right? But remember, we need to realize that these cars do not travel the same distance because one's faster than the other. What we actually want to do here is just multiply the rate times the time. So based on this box that we just filled in, okay, what is the car's one distance, right? Well, it's going to be 2x, okay, because we're just multiplying the corresponding entries, right? X times 2, or just 2x. So similarly, for car 2, we're going to multiply what's in this box, the rate, times the time to get the distance. Okay, so in this case, we'll just put the 2 first, so we get 2 times x plus 10. Okay. So remember, 2x represents car 1's distance, and 2 times x plus 10 represents car 2's distance. Okay. So what's the last thing here? What do we know about the distances, right? We know that they are 160 miles apart. Okay, so what can we conclude then about car 1's distance and car 2's distance? We can conclude that the distances, the sum of the distances should equal 160. Okay, so what do we mean by that? We know that car 1's distance, which is 2x, plus car 2's distance, which is 2 times x plus 10, right? This should equal 160. Okay. And then this is the equation that we want to solve. So from here, we should be able to distribute out the 2 here, so we get 2x plus 20 is equal to 160. We'll combine the like terms here. 2x plus 2x is 4x. At this point, we'll subtract the 20 to both sides to isolate the x term, so 4x is equal to 140. So finally, when we divide by 4 here, we'll divide both sides by 4 to get x, so 140 divided by 4 gives us 35. Okay, so what does this 35 represent? Right. So car 1's distance, okay, so car 1, or the first car, travels 35 miles per hour. And what can we conclude about car 2? Well, it says that the second car travels 10 miles per hour faster, right? So 35 plus 10 gives us 45. So car 2's speed or rate is going to be 45 miles per hour.